If you are trying to run a local agent on a normal Mac, this launch has a catch hiding inside the hype. Meta says Muse Glimmer can run on consumer hardware, but the part that matters is not the headline. It is whether your machine can hold the model, the vision encoder, the drafter, and enough cache to stay useful. In the first minute, I am going to show you Meta's official speed demo, the 24GB target behind its smallest official configuration, and why that official path is a poor fit for a 16GB machine like this one. Then we will separate what Meta actually proved from what still sits in the vendor claim bucket. Muse Glimmer is not another tiny chatbot with a flashy post. According to Meta's model card, it is a dense causal transformer with about 29.6 billion parameters, including a roughly 1.8 billion parameter vision encoder. That matters because the story here is not audio or video generation. The model takes text and images in, then produces text out. Video is treated as frames, not as a dedicated video native model. It is configured for 131,072 tokens of context, which is why Meta is positioning it for long-horizon agent work instead of short single-shot prompts. If you were assuming mixture of experts magic, that is the first correction. This is a dense model with a perception stack, not in most shortcut. The strongest proof in the packet is Meta's own open code workflow. The task prompt is simple and concrete. Discover Home Assistant services, inspect an AV receiver, and build a dashboard. The edited sequence later needs connection information and a long-lived Home Assistant token. You can watch the sequence move from natural language to tool calls, then into service discovery, API inspection, file creation, and command execution. What this proves is not independent reliability. It proves that Meta recorded one edited agent loop with visible intermediate state instead of a single static result screen. That is why I treat this clip as official source footage, not our hands-on test. Still, the clip does show a meaningful chain, a request, visible activity, generated files, and a rendered dashboard. It does not prove that the dashboard reliably controlled a physical receiver or that the model itself ran locally in this recording. The speed story depends on dflash. Meta's drafter predicts blocks of 16 tokens at a time, then the main model verifies them in parallel. That is the reason Meta's edited M5 Max speed demo shows 26.2 tokens per second without speculative decoding and 57.8 with it enabled. The important takeaway is not the exact lab number. It is that Glimmer is being packaged as a local agent model that only feels practical when the drafting path is part of the runtime. If your stack or favorite integration does not expose that acceleration cleanly, the headline experience changes fast. The benchmark table is strong, but it is not a clean sweep. Meta reports wins on MCP Atlas, Deep Search QA, SWE Bench Pro, and several general reasoning tasks. That supports the claim that Glimmer is serious for agentic work in this size class. But the same official table also shows losses that matter. Qwen 3.627b beats it on SWE Bench Verified, Terminal Bench 2.1, Skills Bench, and OS World Verified. So the honest verdict is not that Meta just dropped a universal open-weight champion. The honest verdict is that Meta shipped a credible local agent specialist with real strengths and visible trade-offs, especially once you leave Meta's preferred test mix. Setup is where the marketing phrase runs locally becomes expensive. The BF16 weights occupy roughly 55.5 GB, while Meta targets 64 GB of VRAM for full precision. The official production story gets down to 24 or 32 GB when you use the 4-bit variants. The smaller quant leaves room for cache, the vision encoder, and the drafter, but that still does not make a 16GB Mac a good target. Meta's own safety section also stays mixed. The model card recommends system guardrails and human confirmation for irreversible actions, which is exactly the language you use when a local agent is powerful enough to help and still risky enough to need supervision. My takeaway is simple. If you are a local agent developer targeting Meta's official 24 to 32 GB quantized configurations or more, Muse Glimmer looks like a meaningful open-weight release worth testing. Lower bit community builds may run with less memory, but with extra quality or offloading trade-offs. If you are on a 16GB Mac, or you want a one-click consumer assistant that is already proven beyond vendor footage and vendor benchmarks, this is not your easy answer yet. The Apache 2.0 release matters. The official workflow is credible, but runs locally is not the same thing as runs comfortably on every consumer machine.